Co-location originated on the generation side of the meter, where pairing batteries with intermittent generation sources like wind and solar have become a well-utilized solution to firm up output. Today, co-location is also an essential architecture on the load side of the meter, solving a new set of critical challenges. It is being deployed where frequency and voltage volatility is highest and where pristine power quality is a non-negotiable requirement. Nowhere is this more evident than the hyperscale data center. Operating at hundreds of megawatts with rapid power variability, they challenge the foundations of conventional power system design. At its core, co-location means pairing a generation or load asset with battery storage that has a single point of interconnection with the grid. By bringing their own power capacity on-site, developers can bypass or accelerate the years-long wait for traditional grid expansion. Instead of waiting a decade for the utility to reinforce the infrastructure, co-location allows you to leverage existing capacity today, transforming a delayed project into a connected site. It also enables batteries to act as a shock absorber, smoothing out power fluctuations and ensuring the draw from the grid is smooth and predictable. This has become critical for data centers. Unlike a standard industrial warehouse, data centers house highly sensitive servers that require pristine power quality and leave little margin for fluctuations in voltage or frequency. The challenge is that AI training introduces massive step loads. These are power demands that spike from 0 to 100% and back again in milliseconds. These violent transients outpace the physical limits of traditional grid infrastructure. Conventional power plants rely on the mechanical inertia of massive spinning turbines, heavy equipment that simply cannot ramp up or down quickly enough to match these rapid swings in power demand. And this can lead to severe equipment damage and system instability. This instability doesn't just affect the facility, but also threatens the mechanics of the local grid. This is why utilities are often reluctant to approve massive, volatile loads without first undertaking time-consuming studies and expensive, long-term grid upgrades. By placing battery storage behind the point of interconnection, you introduce an instantaneous response to the site's power profile. The system can ramp up or down in a fraction of a second. By doing this, it absorbs the wild swings in power demand that are unique to data centers. From the grid's perspective, when you co-locate your data center with batteries, your facility no longer looks like a volatile, high-impact burden. Instead, it looks like a smaller, stabilized load that fits within the grid's current limits. This load smoothing effectively de-risks the project, potentially allowing you to secure interconnection approvals years earlier by proving you won't stress the local network. Managing two distinct asset classes at one site creates a level of complexity that basic controllers simply can't handle effectively. Without intelligent orchestration, your asset and your battery can actually end up competing for the same limited inverter capacity. FlexGen's hybrid OS serves as the site's digital brain, providing the precise, real-time coordination needed to navigate complex operational hurdles. For example, if the utility dictates you cannot exceed a 50 megawatt limit on a particularly hot day, hybrid OS intelligently throttles on-site generation while using the battery to bridge the gap. This ensures the data center stays at 100% capacity without ever violating the grid's cap. And during a total grid failure, the system can island the site to keep the servers running independently. When the grid returns, hybrid OS will manage the delicate resynchronization process, matching the utility's frequency perfectly to prevent any dips in power quality that would otherwise trigger costly outages. Ultimately, co-location serves as the critical release valve, minimizing the impact of curtailment on both sides of the meter. It enables generators to maximize their yield while providing the fast response, full capacity power that modern loads require. FlexGen is leading the transition with full wrap solutions powered by hybrid OS. Learn how we can de-risk your next project at flexgen.com.